welcome to today's class. Today we shall deal with the solid state. Solid state. So what are the how to crack this solid state? How to crack this solid state? What are the important things that are to be covered? Let us first try to know the headings that are to be covered in the solid state. Now classification, first thing is classification of the solids. Classification of the solids. So classification of the solids means in this there are, what is the broad classification? Crystalline and amorphous. Crystalline and amorphous solids. And crystalline solids will have the definite pattern of arrangement of the particles, definite melting point and boiling points. They will be anisotropic. That is, the physical properties will be different in different direction. That arises due to the difference in the pattern of the arrangement of the particles. Amorphous will not have sharp melting point. The regular pattern of arrangement is limited to short range, and in this case they are isotropic, that is physical properties in all directions will be similar. After that, types of the solids. Crystalline solids can again be divided into molecular solids, ionic solids, metals and network solids. So we have to know about these things: molecular solids, ionic solids and metals and network solids. What should we know regarding this, the type of the solids? What are the constituent particles, how they behave, what is their electrical behavior, and all these points. What are the examples for molecular solids? We have to know what are the constituent particles. Under the heading the types of the solids, what are the points you have to remember? What are the constituent particles? What is their electrical behavior? What is their magnetic behavior? These points are to be known regarding the types of the solids. After going to the types of the solids, after going through the types of the solids, because we can expect theoretical questions in the introduction part also. Next we have to go to the unit cells and space lattice. What do you mean by space lattice? The pattern of arrangement of the particles in 3-dimensional region or 2-dimensional region is called space lattice. And unit cell, what is unit cell? The smallest geometrical portion which on repetition generates the entire lattice is called unit cells. We can have unit cells in 2-dimensional region, in a 2-dimensional region and a 3-dimensional region, 3-dimensional pattern. Now in our present discussion we will mainly discuss about the 3-dimensional unit cells. What are the important 3-dimensional unit cells we have? We have face-centered FCC, BCC, simple cube and end-centered unit cells. So we will mainly, our today's discussion is mainly will be focused on the analysis of these types of the solids. After coming to know the types of the unit cells, we have to discuss about the analysis of the unit cells. Let us briefly discuss what is the analysis we have to do regarding these unit cells? What is the analysis of the unit cells? Now, the first point is cell constant. Cell constant. What is cell constant? Number of the effective atoms per unit cell. Number of effective atoms per unit cell. In FCC, what is the number of effective atoms? 4. In BCC, what is the number of effective atoms? 2. And in simple cube, what is the number of the effective atoms? 1. In end-centered cube, what is the number of the effective atoms? 2. Number of effective atoms. In FCC, the lattice positions are being occupied by 6 faces and 8 corners. 6 faces and 8 corners will be occupied. In BCC, 1 center of the body and 8 corners will be occupied. In BCC, 1 center of the body and 8 corners will be occupied. In simple cube, only corners are being occupied. In end-centered cubic unit cells, apart from the corners, 2 centers of 2 alternate faces will be occupied. This calculation is important. What is the contribution made by the lattice point occupying the center of the corner? 1/8. A point lying at the corner will make a contribution of 1/8 to the unit cell. A point at the center of the face will make contribution of 1/2. A point at the center of the edge will make a contribution of 1/4. A point at the center of the body will make a contribution of 1 to the unit cell. So, this is the first important point. After this, we have to come to the density. What is how to calculate the density of the cubic density of the cell? Z into m by n into a cube. How do you get density? Total mass by volume. So, mass of how many? This Z, what is Z specifies? Z specifies the cell constant, that is number of effective atoms in an unit cell. M stands for atomic weight, atomic mass of atom of atomic weight, and Avogadro's number. A stands for volume. After this, we have to come to the calculation of the packing fraction. This is also an important thing. How to calculate the packing fraction? So, packing fraction means total volume occupied by the atoms, in the unit cell, divided by volume of the unit cell. These calculations are very important. Packing fraction. After packing fraction, what is the other important thing? Other important thing is distance between the neighboring particles. Distance between the neighboring particles. In case of this is most important, calculation of distance between the neighboring particles. In simple cube, what will happen? 2 spheres touch along the edge length. 2 spheres touch each other along the edge length. Then what will be the d? It will be equal to a. What will be the distance between the neighboring particles? It will be equal to a. What will be the r value? It will be equal to A by 2. What is R stands for? What is R stands for? Radius of the sphere. When two spheres touch each other in a simple cube, what will be the distance between the neighboring particles? It is nothing but A, and R will be equal to A by 2. In simple cube, what is the number of effective atoms per unit cell? 1. Then how to calculate the packing fraction in the simple cube? Packing fraction is equal to total, how many atoms are there? 1 atom. 1 into, what is the volume occupied by 1 atom? 4 by 3 pi r cube. 4 by 3 pi r cube by, what will be the volume of the unit cell? A cube. What is the A value? What is the A value? A is equal to 2r. A is equal to 2r. A cube is equal to 8r cube. A cube is equal to 8r cube. Substituting in that, packing fraction is equal to 4 by 3 pi r cube into 1 by 8r cube. R cube gets cancelled out. So it is pi by 6. Pi by 6. What is pi by 6? 22 by 7 into 6. It comes around 0.524. So what is the percentage of the space occupied? 52.4. What is the percentage of the unoccupied space? 47.6. This is the way to calculate the packing fractions. This is very, very important. In FCC, what will be the packing fraction? 74%. In BCC, what is the packing fraction? 68%. After calculating the packing of the fraction, we have to go for the types of the closed packing. Types of the closed packing. So here there are broadly two types of closed packing. One square closed packing. One square closed packing. In this, spheres are placed, the spheres are vertically aligned. In this, the packing fraction value is less. In this, the efficiency of the packing is very less. There are two important closed packing, CCP, HCP and CCP. In this HCP, in the HCP type of the closed packing, what will happen? Third layer of the spheres will be placed on the tetrahedral voids of the second layer of the sphere. This gives rise to AB type. In CCP type, we will have the ABC pattern. What does it mean? First and fourth layers will have the similar pattern of the arrangement, and we have to go through the types of the closed packing. After types of the closed packing, we have to know voids. There are mainly two types of the voids. One is tetrahedral void and octahedral void. So tetrahedral void is produced. What is tetrahedral void? Empty space among the four spheres. When four spheres are in contact with each other, the empty space in between the four spheres is called tetrahedral void. What is octahedral void? The empty space between the six spheres is called octahedral void. Generally, voids are observed in the FCC types of the crystals. And what will be the number of the tetrahedral voids and octahedral voids? If a sphere has, if a crystal has n spheres, number of tetrahedral voids will be 2n, and number of octahedral voids will be n. Generally, in general, anions occupy the lattice position, cations occupy the interstitial voids. What is the radius of the tetrahedral void? 0.225 into radius of the anion. And what is the octahedral void radius? 0.414 into radius of the anion. This calculation is also important. This calculation is also important. Next, what is the other point? Types of crystal systems. All the crystals are arranged in 7 patterns based on the edge lengths, and interfacial angles. There are 7 types of crystal lattice systems. 7 types of crystal system. So we expect to get 28 unit cells. 28 unit cells. Because what are the primary important unit cells we have? Simple cubic, FCC, BCC, and end-centered cubic unit cells. 7 crystal systems are there. So we expected to get 28 unit cells. But what is how many unit cells are existing? 14 unit cells. These 14 unit cells are known as Bravais lattices. A tabular form with regard to the crystal systems must be go through. So students are advised to go through this 7 crystal systems. It is which is formulated based on the edge lengths and interfacial angles. Now let us discuss the remaining concepts through the questions. Come on. Sodium and magnesium crystallizes in BCC and FCC types of the crystals. Then number of the atoms of sodium and magnesium in the unit cell. Sodium BCC assumes BCC and magnesium assumes FCC. Therefore, what is the number of cell constant for BCC? 2. For what is the cell constant for this? 4. So effective number of the atoms of sodium per unit cell is 2 and magnesium is 4. Option 4. Next, potassium crystallizes in a body-centered cubic unit cell. So when a potassium assumes body-centered cubic cell, then number of atoms in the unit cell is equal to 2. Unit cell is equal to 2. What is the mass of the unit cell? Mass of the unit cell 2 into 39 AMU. 2 into 39 AMU. Because weight of single potassium atom is 39 AMU. Because since it contains 2 atoms per unit cell, 2 into 39 AMU, that is 78. What is the value of AMU? 1.66 into 10 to the power of minus 24. So the value comes to 1.295 into 10 to the power of minus 22. Option 2 is the answer. Next, a metal M is crystallized in FCC lattice. The number of unit cells in it having. So what is each unit cell will have? Each unit cell will have how many atoms? Will have 4 atoms. 4 atoms. So total number of unit cells is equal to number of the atoms by 4. Number of atoms by 4. What is number of the atoms? 2.4 into 10 to the power of 24 by 4. It is equal to 6 into 10 to the power of 23, which is equal to Avogadro's number. Next, option 1 is the answer. Next question. For crystal, this is a Bragg's equation. What is the equation for the Bragg's equation? N lambda is equal to 2d sin theta. M lambda is equal to 2d sin theta. 2d sin theta. Here 2 theta is equal to 90 degrees, implies theta is equal to 45 degrees. Sin 45 degrees is equal to 1 by root 2, which is equal to 0.7. For this crystal, the second order line So 2 into lambda, 2 into lambda is equal to 2d into sine theta. What is d? 2.28. 2.28. What is sine theta? 0.7. Cancels out. Lambda is equal to 1.67 Armstrongs. Option 1 is the answer. Next. This is also, here we have to find d value, the first order diffraction. So 1 into lambda is equal to 2 into d into, what is sine theta? Sine 11.8. Sine 11.8 is equal to 0.2. What is the lambda value? They have given 0.2 nm and part. So lambda is equal to, d is equal to 0.281 nm. G is equal to 0.281 nm. And what is sine theta value? 0.2. Simplifying it, we will get the lambda value as 0.1124 nm. Option 1 is the answer. Next question. If X-rays of diffraction, which one of the following difference between the two waves are destructive interference? For the interference to be constructive, for the interference to be constructive, 2d sine theta must be equal to n lambda, where n should be an integer. So in the option 4, n has taken fractional value, so it will lead to destructive interference. Option 4. Next, at what angle first order diffraction of the distance between the two adjacent planes of the crystals is equal to the X-rays first order? So L lambda is equal to 2d sine theta. So for lambda 2 equal to d, 2 sine theta must be equal to 1. This can happen when theta is equal to 30 degrees. So option 1 is the answer. For lambda to be equal to theta, 2 sine theta must be equal to 1. So that can happen when theta is equal to 30, because sine 30 is equal to 1 by 2. Next question. If two waves with the amplitude, if they reinforce each other, what will be the amplitude of the resulting wave? It is nothing but 2E naught. Next question. Option 3 is the answer. How many atoms are there? Having one atom on each corner and 2 atoms on each body diagonal. So in a cubic 4, there will be number of body diagonals will be 4. In a cube, how many body diagonals will be there? 4 body diagonals. Number of body diagonals will be 4. So total number of the atoms on the body diagonals will be 2 into 4, 8. And number of corners occupied, 8. So each corner will make a contribution of 1 by 8. So 1. So total number of the atoms will be 8 plus 1, 9. So in a cube, how many body diagonals will be there? 4. Each body diagonal, on each body diagonal we have 2 atoms. So total number of the atoms on the body diagonal is 8. And when each corner is occupied, 8 corners are occupied, what is the effective contribution? 1 by 8, 1. 8 plus 1, 9. Answer is 4. Next. So in a closed packed, if A particles are there, number of tetrahedral voids will be 2A. Number of tetrahedral voids will be 2A, and number of tetrahedral voids will be 2A, and number of octahedral voids will be A. The number of octahedral voids in a cubic closed packed structure is, in a cubic closed packed structure in CCP, number of effective atoms will be 4. cubic CCP or FCP, both one and the same, both are one and the same. So number of effective atoms will be equal to 4 and number of octahedral voids will be equal to 4. Option 3 is the answer. Next, a body centered cubic cell is made of two elements A and B. A occupy two corners of the cube and remaining positions of the unit cell are occupied by B. What is the formula of the compound? So in a BCC, what is the lattice positions? 8 corners and one center of the body. One center of the body will be there. So number of effective atoms, number of effective atoms of A, number of effective atoms of A is equal to 2 into 1 by 8, because 2A atoms of 2A atoms occupy, atoms of A occupy 2 corners. From each corner, what is the contribution we get? 2 in 1 by 8. So number of effective atoms of A is 1 by 4, and B occupies 6 corners and one center of the body, So what is the effective number of atoms of B? 6 into 1 by 8 plus 1, 3 by 4 plus 1, it will be equal to 7 by 4. Now what is the ratio? A is to B is equal to 1 by 4 is to 7 by 4, which is equal to 1 is to 7. So the formula is AB7. So what can be the lattice position in BCC? 8 corners, one center of the body, out of which 2 corners are being occupied by A, 6 corners and one center of the body is occupied by B. The formula is this. AB7. Option 3 is the answer. Next, you can mainly expect this type of the questions in the solid state. A solid W has a structure in which W atoms are located at the corners, oxygen atoms are at the center of the edges, and sodium atom is at the center of the cube. What is the formula? So effective number of sodium atoms is equal to 1, because it is occupying the center of the cube, so it is 1. And W atoms are located at the corners, so number of effective atoms of W is equal to 8 into 1 by 8, 1. Oxygen atoms are at the center of the edges, so effective atoms of oxygen is equal to 12 into 1 by 4, it is 3. So the formula is NaWO3. NaWO3. Option 3 is the answer. Next, a compound formed by elements X and Y crystallizes in which X atoms are at the corners of the cube and Y atoms are at the face. What is the formula? So number of effective atoms of the X is equal to 8 into 1 by 8, 1. Number of effective atoms of Y is equal to 6 into 1 by 2, 3. The formula is XY3. Option 4 is the answer. Next, this crystallizes where the A atoms are at the corners and B atoms are at the center of the body. What is the simple formula? A atoms are at the corners of the cube, B is at the center of the body. So number of effective atoms of A is equal to 8 into 1 by 8, 1, and B is equal to 1 into 1, 1. Simple formula of the compound is AB. Option 1 is the answer. Next question. In a compound of atoms of element Y forms CCP lattice and those of element X occupy 2 by 3, 2/3 of the tetrahedral voids. What is the formula of the compound? Element Y forms CCP lattice. So let let effective number of Y atoms is equal to 4, because it occupies a it assumes a CCP lattice. Even if we can assume it as n, number of tetrahedral voids present will be, number of tetrahedral voids is present is 2n. Number of effective tetrahedral voids occupied, is equal to 2/3 of 2n, 4n by 3. Now what is the ratio? N is to 4n by 3. What is the ratio of x is to y? X is to y is equal to, x is 4n by 3 and y is n. So x4 y3. Option 4 is the answer, because number of effective atoms of Y is equal to 4. Even if you don't know this number, it doesn't matter, you assume it that as n. What will be the number of tetrahedral voids present in a cube? 2n, out of which 2/3 are occupied. So number of effective atoms of X is 4n by 3, effective atoms of Y is n. The ratio is x4 y3. Option 4 is the answer. Next, in the crystals of which of the ionic compounds you expect maximum distance between the center of the cation and the center of the anion? The logic is simple. Larger cation and larger anion. Where is larger cation and larger anion? In the option 3. So option 3 is the answer. Next question. When molten zinc is cooled to solid state, it assumes HCP structure. Then the number of nearest zinc atoms in HCP, number of nearest neighboring atoms is nothing but coordination number. In HCP, the coordination number is 12. In HCP, coordination number is 12. So number of nearest atoms will be 12. Option 4 is the answer. If HCP is formed by an ionic compound, then number of oppositely charged ions, then coordination number will be 6, because it is the HCP is formed by one type of the particles, that is zinc. What is the coordination number here? 12. Next, the percentage void of the space in ABC type, this is nothing but calculating what is the packing fraction for the CCP type. CCP and HCP, packing fraction for CCP and HCP will be 74%. So percentage of the empty space will be 100 minus 74, 26%. 26%. Option 2 is the answer. For CCP and HCP, what is the packing fraction value? 74%. Next, in a simple cubic unit cell of edge length 6.22, and what is the radius of the metal? So in a simple cube, D is equal to A and R is equal to A by 2, 6.22 by 2, 3.11 Armstrong units. 3.11 Armstrong units. Option 2 is the answer. Next, sodium metal crystallizes in a body-centered cubic lattice with the cell edge A 4.29, and what is the radius of the sodium metal? Sodium metal is a BCC. For BCC, D is equal to, what is meant by D? Distance between the neighboring atoms, √3 by 2 A. R will be equal to √3 by 4 A. Now R is equal to √3 by 4 into what is A value? 4.29 Armstrong units. It will be root 3 into 1.07 Armstrong units. It comes around 1.86, 1.732 into 1.07, 1.86. Option 3 is the answer. In FCC system, D is equal to A by root 2, R will be equal to A by 2 root 2. A by 2 root 2. What is A? 3.63 by 2 root 2. If you simplify, we will get the answer as 1.28, because 1.815 by 1.414, it comes around 1.28. Option 3 is the answer. Next, the radius of an atom of an element is 80. If it crystallizes in a body center, what is the edge length? In a BCC, what is the relation between radius and the edge length? R is equal to root 3 by 4A. A is equal to 4 into R by root 3. So what is R value? 80. 4 into 80 by root 3, 1.732. It must be around 160 or 184.7 pm. 185.7 pm. Simplifying it, we will get the answer as 184.7. Answer, option 2 is the answer. Next, a metal has BCC structure and volume of the unit cell. How do you get volume of the unit cell? A cube, which is equal to 3.04 into 10 to the power of minus 28 whole cube. So it comes around 22.81 into 10 to the power minus 23 cc. Option 2 is the answer. Next, in an ionic compound, distance between the neighboring particles is nothing but radius of K plus and radius of the F minus. Which is equal to 133 plus 136, 269. 133 plus 136, 239. Next, 269. 269 pm. Next, this zirconium hydride is called Bethel halide compound. It is a point to be remembered. Option 4 is the answer. Next, the formula of an oxide of iron is Fe 0.93 and O. If the compound has 100 oxygen atoms, then it contains. So what is the point here? 100 total negative charge, because it is a neutral compound. Since this compound is a neutral compound, total negative charge must be equal to total positive charge. What will be the total negative charge? Total negative charge on the oxygen atoms. Total negative charge on the oxygen atoms is 100 minus 2, 200 units. So total positive charge on iron atoms must be equal to 200 units. 200 units. Out of 93 atoms, if X atoms exhibit take +2 oxygen state, 93 minus X atoms will exhibit +3 oxidation state. So X into 2 plus 93 minus X into 3 must be equated to 200. What is the logic here? Total positive charge on the iron atoms must be equated to 200 because this is a neutral compound. Total negative charge must be equal to total positive charge. Out of 93 iron atoms, if X atoms assumes +2 oxygen state and 93 minus X atoms will assume +3 oxygen state. So total charge, positive charge must be equated to 200. Solving, X will be equal to 79. Implies 79 atoms will have +2 and 14 atoms will have Fe +3, and option 3 is the answer. Next question. The crystal system of a compound with an unit cell dimensions. Here A is not equal to B. Here A is not equal to B. A is equal to B and it is not equal to C. So two edge lengths are equal. Two angles, interfacial angles are equal. This is the characteristic property of hexagonal crystal system. So answer 2. There is a tabular form. How many crystal systems are there? 7 crystal systems are there based on edge lengths and their interfacial angles. When two edge lengths and two interfacial angles are equal, then that system belongs to hexagonal system. Next, 3 metals XYZ are crystallized in simple cubic and BCC and FCC lattice. The number of unit cells in 1 mole each of the crystals each crystals respectively. In X, what is the number of the Z value for X? What do you mean by Z value? Cell constant. Z value for X is equal to 1 and Z value for Y is equal to it is a BCC 2 and Z value for the, what do you mean by Z? Cell constant for Z. For cell constant for X is equal to 1 and for Y is equal to 2, for Z is equal to 4. That is, what do you mean by cell constant? Effective number of the atoms in a unit cell. Now what is the number of the unit cells in 1 mole each of this thing? How do you calculate the number of the unit cells? Total number of the atoms by cell constant. For X, Y, Z, total number of the atoms in each mole is N. What is the cell constant here? 1. Here N by 2. Here N by 4. So in this ratio, this is the ratio. Option 1 is the answer. Next question. In a FCC centered cubic, A and B atoms, A atoms are at the corners of the units and B atoms are at edge centers. One of the atom A is freezing from the one corner in each unit cell. What is the simplest formula? So that is number of corners occupied by A is 7. occupied by A is equal to 7, because there will be total 8 corners will be there, out of which 1 corner is missing, means number of corners occupied by A is equal to 7. Therefore, number of effective atoms of A is equal to number of effective atoms of A is equal to 7 by 8. 7 into 1 by 8, 7 by 8. Now B atoms are at the edge centers. B atoms are at the edge centers. Number of effective atoms of B is equal to 12 into 1 by 4. There will be 12 edges, and what is the contribution from the edge center? 1 by 4, that is equal to 3. Now what is the ratio? A is to B is equal to 7 by 8 is to 3, that is equal to 7 is to 24. What is the formula? A7 B24. A7 B24. That is nothing but A 7 by 8 and B by 3. Option 4 is the answer. Next. In a hypothetical ionic crystal, B arranged in cubic lattice, A occupies all octahedral voids and alternative tetrahedral voids. The correct formula of the Z is, let effective number of the atoms of B is equal to, let effective number of the atoms of B is equal to n. B is equal to n, and tetrahedral voids will be equal to 2n, and octahedral voids will be equal to n. Octahedral voids is equal to n. So number of effective number of atoms of A is equal to because A occupies all the octahedral voids n, and it occupies half of the tetrahedral voids, so 2n. And what will be the formula of the AB? This is 2n, this is n, so A to B is the answer. Option 4, because A occupies all the octahedral voids, that is number of octahedral voids is n, half of the tetrahedral voids n, 2n atoms of A, n atoms of B. What will be the formula? A to B. Next. In a metal oxide ions are arranged in HCP, and metal ion occupies octahedral voids. If 1/3 of the octahedral voids and all tetrahedral voids are empty, and then what is the metal oxide formula? What is the oxide number of oxide ions? Number of oxide ions is equal to n. Now A occupies, what is 1/3 octahedral voids are empty. Octahedral voids is equal to n. Number of octahedral voids occupied is equal to 2 by 3n, because n minus n by 3, 2n by 3. All tetrahedral voids are empty, so number of octahedral voids occupied by A is equal to 2n by 3. What is the formula of the metal? What is it? So metal, this is metal. What is the formula of the compound? MO, 2n by 3 n, so 2 is to 3. The formula must be M2O3. Option 2 is the answer. Next question. In a compound, oxide ions will have CCP. Cations are present in 1/8 of the tetrahedral voids. Cations occupy the half of the octahedral voids. what is the simplest formula of the compound? So number of oxide ions is equal to N. Number of oxide ions is equal to N. And A cations A are present in 1/8 of the tetrahedral voids. Number of A atoms is equal to 1/8 of 2n. 1/8 of 2n. 1/4n. 1/4n. And 1/8 of the tetrahedral voids. Cation B occupies half of the octahedral voids. Number of B is equal to half of the octahedral voids. 1/2n. 1/2n. Now what is the ratio? ABO. ABO 1/4n and 1/2n and n. So A1 B2 O4. AB2 O4. Option 1 is the answer. Next. X52O4. Oxide ions or X atoms are present in octahedral voids. Cations Y are equally distributed between octahedral voids and the tetrahedral voids. The fraction of the octahedral voids occupied is, what is the in a compound? XY2O4. 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 What will be the number of octahedral voids? What will be the number of octahedral voids? 4. What is the number of tetrahedral voids? 8. 8. Now what is given? What is given? Cations Y are equally distributed between octahedral voids and tetrahedral voids. Octahedral voids and tetrahedral voids. So total number of the Y atoms is 2. It is equally number of effective Y atoms is Y atoms is equal to 2, out of which one atom occupies octahedral void, one atom occupies tetrahedral void. What is the fraction of the octahedral voids occupied? What is the cations Y X are present in the octahedral voids. Cations Y are equally distributed in between octahedral voids and tetrahedral voids. So number of octahedral voids occupied by Y is equal to 1. Number of octahedral voids occupied by X is equal to 1. So total number of octahedral voids occupied is equal to 2. Fraction occupied is equal to fraction of the octahedral voids occupied is equal to 2/4, that is equal to 1/2. So number of effective atoms of Y is equal to 2, out of which one atom is in octahedral void, one atom is in the tetrahedral void. X is present in the octahedral void. So X occupies one octahedral void, Y occupies one octahedral voids. 2 octahedral voids are occupied, but how many octahedral voids are present? 4. So what is the fraction of the octahedral voids occupied? 1/2. Next. Edge length of the cube is 400 pm. Then what is its body diagonal? What is its body diagonal? Length of the body diagonal is root 3a. Length of the body diagonal is root 3a. So root 3 into what is the edge length? 400 pm. The answer comes to 693 pm. Option 3 is the answer. Argon crystallizes in FCC lattice. Edge length is 5.31 Armstrong units. And what is the distance between the neighboring particles? In FCC, distance between the neighboring particles is equal to A by root 2. 5.311 by 1.414. 5.311 by 1.414. It must be 3.755. Option 1 is the answer. Edge length is given. How to find the density? What is the formula for density? Z into m into n by a cube. Z into m into n into a cube. N into a cube. Now, what is Z value? In BCC, Z value is 2. What is the atomic number? 23. What is 6.023 into 10 to the power of 23 into what is the edge length? 0.424. So, what is Z value here for BCC? It is 2. Simplifying this, we will get the answer. Option 3 is the answer. Next. A metallic element exists in simple cubic structure. Each edge of the unit cell is 3 Armstrong units. The density is 10 grams per. How many unit cells will be there in 16.2 grams of the metal? 16.2 grams of the metal. Here, what is the point here? Number of unit cells. What is the formula? Number of unit cells is equal to total number of the atoms by cell constant. So, how do you get total number of the atoms? 1 atomic weight of the m grams. What is m grams? Atomic weight of the element. 1 m grams will occupy 16 to 10 to the power of 23. And what is the weight of this thing given? 16.2 gives us to how much? So, first we must find the atomic weight. How to find the atomic weight? From the expression of the density, D is equal to Z into m by n into a cube. What is the density given? 10. What is the Z value? It exists in simple 1 into m by 6 into 10 to the power of 23. What is the edge length? 3 Armstrong units. 3 into 10 to the power of minus 8 centimeters whole cube. From this we will get the atomic weight, and from this m grams will contain 6 into 10 to the power of 23. 16.2 grams will contain how much? So, now how to find the number of the unit cells? Total number of the atoms by cell constant. Since it is a simple cube, cell constant will be equal to 1. So, total number of the atoms we have to find. M grams contains 6 into 10 to the power of 23. 16.2 grams contain how much? We have to find the m value from this equation, and from that we have to find the total number of the atoms. By solving it, we will get the answer. So, I hope the students will get immense benefit from the classes conducted by the cab televisions, and due to the time constraint, we are not able to discuss the another important chapter, surface chemistry. Surface chemistry has 4 important topics. One is adsorption. In the adsorption also we have to read about the isotherms of the adsorption isotherms, and in colloids, you have to be careful regarding the examples, and gold number and this coagulating power of the different protective agents, and in the catalysis you have to go through the theories of the catalysis. I hope all the students must have been immensely benefited with the program brought out by the cab television. I wish good luck for all the EAMCET and NEET writing students. Thank you very much.